Hey teacher, are piles of marking getting you down? The stack keeps growing and the end of term keeps coming closer and you never seem to be able to catch up.
That's
Well,
me.
now you can. Learn from Jason Brett, BCIT instructor and marking expert, often known for getting assignments back to students in the very same semester in which they were submitted. Jason doesn't mark by hand anymore. He's stopped throwing things down the stairs. He uses the assessometer. Using the latest in artificial intelligence technologies, you no longer have to even open the cover. Just put the assessometer on top of the book and press the button. The artificial intelligence algorithms go to work scanning the document every page to come up with the perfect mark for this assignment. What's it going to be? It's coming up with an answer, and this one is a C. Well done. Nice. What's up next? Here we go. Wow, that would take a long time to read. I think that's thesis quality. Let's see what it's going to be. It's processing. It's processing. And it is an F. Oh, something wrong with that one there. The assessometer contains all the options that you need to fairly and adequately assess your students' projects. They can achieve an A, a D, a C, a B. Oops, lost it. They'll have to submit. C, C plus, C minus, A plus. It's all there in the assessometer. All you need to do is grab the assignment, put it on top, and let artificial intelligence go to work for you. Oh, an A. Excellent work. No more wearing out your red pens. Throw them away. You don't need them anymore. You've got the assessometer. Call now. 555 4017. $30.96.
Well, I thought I'd start off with a little more dynamic introduction to one of my projects here for us to route in BCIT's Technology Teacher Education 4035 class, where we're learning how to use Fusion 360's electronic design modules to create printed circuit board designs. And so today I've got a classic assignment for you, and it uses a 555 timer and a 4017 chip to create what has commonly been called a roulette project. But I've got a couple of different formats that you can build it in. I've packaged this one up as the SSometer, but honestly, the acrylic insert right here could easily be taken out and replaced with any other acrylic insert, so you could put whatever options you wanted in there, or you could do it up as a rectangular board, and this one I've called the procrastinator, and it kind of works the same way. It's got the 555 4017. It's the exact same schematic. It's just laid out in a rectangular format, and it says that I should go for a run instead of making this video. So anyway, I've got a few other things here that we're going to talk about as we go along. But the first thing I wanted to mention is, if you haven't seen my video, DIY printed circuit board terms for the beginner, it's on my YouTube channel right here. I've got links to it from my Desire to Learn page for students in the class, and it's going to walk you through a bunch of the terms that we've been using as we go along right in here. Single-sided boards, double-sided boards, through holes, vias. We're not going to get to the solder mask today, and we're definitely not going to be designing multi-layer boards, but it's worth knowing that that's out there and that you can do cool things like that. The circuit that we're actually looking at today is not a new circuit by any means. I probably made one when I was in high school, and anyway, electronics teachers at the BC Tech Ed Association conference have been telling me that their students really enjoy this one. So I thought it was time to bring it back and use it, because I think it's going to be a good and interesting routing challenge for you to take on. Now, the particular schematic that I downloaded, I grabbed from a website called elonix.org, which actually has a lot of good electronics project on it here. It's got an example of how to put it together on a breadboard. in a
Hi, welcome to Elonix.
nice
Connect pins 2 and 6
little
through the
breadboard
collector and emit
format.
a signal.
Talks about how the circuit comes together and
The
tells you a little
speed
bit
of
about how
rotation
it
of the
works.
LEDs is controlled by the frequency of clock input signal, which
And so it's got that all written up down here, and it's got the schematic laid out like this. And I've got the exact same schematic that I've got laid out for you in class, except I've drawn out in a way that I like it a little bit better, and I'm going to be working from that schematic. I also have on my handout for you, and I'll put this up on the screen a little bit bigger in a moment, a list of the parts and the libraries that I'll be drawing them out from. Okay, so if you want more information on how the circuit works, that's elonix.org LED roulette circuit using 555 timer 4017 IC. But if you just Google Elonix and roulette, the web page is going to come up for you. And if you're interested in other electronic circuits, go to their homepage, and it's got a whole bunch of interesting and useful information about electronics. So let's get that out of the way right there, and let's get on to taking a look at how we're going to make this circuit in Fusion 360. So the first thing I should do is make sure that everybody's got a copy of the handout. Now, not not everybody's going to have a paper handout, so what I'm going to do is I'm just going to take this window right here and drag that up full screen so that you've got, there you go, nice clear shot of the circuit. I can shine a little bit of light on that, see if that makes it come through a bit better. And there's the schematic that we're going to be working from. And here's down at the bottom, a list of the parts that we're going to use and where we're going to grab them from. Okay, so if you don't have a copy of my handouts and you can't grab them from the D2L because you're not in the class, maybe grab a screenshot of that and you can refer to that as we go along. Now, this is about the third or for the fourth video in our series here, and we're a couple of assignments in. So I'm not going to spend a lot of time taking a look at how to build the schematic. So I've got the schematic all drawn here on my screen, and I've actually been able to do something kind of cool right on here. When I start a new project, I can actually reference a schematic that I've used in a previous design. So you see on here, I've got an LED roulette wheel, but I've also got the procrastinator with the rectangular format. We'll take a look at a little bit about how to do both of those layouts today. But anyway, here's the schematic, and I'm just going to get rid of this, make the window a little bit bigger. There's another way that you can grab a screenshot of the schematic that we're going to be working from. And again, down in the bottom corner here, I've got a list of all the parts that you can insert into there. As with any of our circuits, it's really important that you get the schematic right, because everything that you do after that and all your design rule checks is going to depend on how that schematic comes together. So double check and make sure that everything goes together sensibly on here. One thing I've noticed that people have been running into a little bit of trouble with is when they're connecting their grounds. Okay, let me just come in here and I'm just going to click on this line right here and I'm going to delete it. So the ground is in there. Now, at the moment, this gives us a net right in here. And this net, when I click on it, has a name, and this net says N $9 right over here. So you can see right over on this side, I click on there, and the net represents the logical connection between the pins. So 13, 15, and 8 are all connected together. And if I click right there, okay, 13, 15, and 8 are still connected together by net 9. If I click on a different net, that net over there is going to have a name of net 5. Now, when you go and you connect ground to that, okay, ground also has a net name. Pardon me, I just need to tell it that I'm connecting a net. Ground also has a net name. And when I connect it like that, it's going to ask me, do I want to merge net segment N9 into net supply ground? In other words, do I want to connect this to ground and make it all ground? Okay, and to that, I say yes, because now when I click on there, okay, oh, just a minute, stop drawing lines. When I click on there and I get the properties, you can see that my net is now named ground, GND, which is the same net that is ground, GND, right over here. And that's how the Fusion knows that those have to be connected on your board. Where people have been running into problems is, let me delete this right here. And if I draw this net right here, and I bring it down this way, okay, I could click no on that, okay, and then it doesn't join right there. Sometimes you'll also have it hooked up, and maybe it's when I connect from ground up to right here. And no, that's also asking me in the correct direction. Sometimes it will ask you, do you want to merge net into ground? And if you do that, then you end up with a problem where your ground down here ends up becoming net 9. So let's just check on there. Double check, and that still says GND. So anytime you want to make sure your nets are connected properly, you can just click on a section right there. That's net 13, and everything that's connected to it should also say N13 right over on that side as we go around the window taking a look. Okay, so just a good thing to keep in mind when you're laying out your schematic. Okay, now I've got the schematic inside my project. Okay, and my project is sitting right here. I am going to save that with a new name. This is going to be 4017-555 demo project. And I'm going to assume that you're able to go and find the parts in the libraries and put a nice little schematic together here like this. When you've got that schematic built, okay, you can come over here and, oh, there was the schematic. When the schematic's all built, you can come in here and do as usual and start a new PCB document. And if you've drawn your schematic correctly, when the PCB document comes up over here, all of your parts are going to be sitting right here waiting for you, and you can just grab them and move them onto the board right here. Okay, and there's all your components, and you've got all those air wires that look a little bit confusing to get started, but hopefully you're getting used to what they mean right now and why they jump around a little bit as they move, and you're going to be a little bit more comfortable working with them. Okay, now one of the neat things about this project is that we often want to have the LEDs put together into a certain pattern. So if you want to do the roulette wheel style or the accessometer style, then you're going to want to have your LEDs in a circular pattern, and you're probably going to want to make it on a circular board. Whereas if you're more interested in the vertical pattern right here, you're going to want it onto a rectangular board. And then you can do something up like the procrastinator and, you know, start thinking about what you're going to make, okay? I mean, yes, you can make a roulette wheel. Yes, you can come up with an accessometer type of idea. Yes, you can come up with a procrastinator, but maybe there's something that you'd like to put onto your board to have it help you make important decisions. The only thing that I'm going to ask is that you build at least one of these that is teacher regulation branch compliant and that you can show it to your students. So if you want to make one deciding whether or not you should have whiskey, wine, beer, or whatever as your after dinner drink, then go ahead and make that as your second one, but make sure you've got a good one to take into the classroom as an example, because this is something that you can have sitting on the shelf behind your desk in your shop, and it's kind of fun to just hook it up and you know, maybe this is your detention taskometer or something like that, although who knows, nowadays the teacher regulation branch probably doesn't even approve of detention. Discipline for a child. I've got to renew my membership. Anyway, let's take a look on here at some of the things that are going on. Now, I'm just going to blast this window a little bit bigger before I start designing things, because I want to talk a little bit about some of the challenges that come up in circuit board design right here. And I couldn't route everything onto one layer. There's just too many nets and they were crossing over top of each other. So I had to use these things called jumpers. And you see here I've got 4 yellow wires right on here. And those are yellow wires that are actually on the top layer of my drawing. Okay, and those yellow wires got me out of some routing situations that I wasn't able to solve, because if you look at where they run on the back, that yellow wire comes right over there, jumps right over to there, and you can see underneath it that there's a whole bunch of traces that it jumps over top. Now, that is one of 4 jumpers that I've built on there, and I really don't like jumpers. I mean, I do. They make it possible to make boards. They sort of let us simulate having a 2-layered board without actually having a 2-layered board. Um, but I prefer to avoid them. They're extra work. You've got to cut extra wires. They take up space on the top layer. So this was my prototype. This was a fast one-off circuit that I did. And I said, after I built it, I said, okay, my schematic works. I know I can do it better. I'm going to come back and make it on a smaller board. And this is the board that's inside the accessometer. This one's not quite finished. You can see where the LEDs are going to go. I made it smaller, and you'll notice that this one only has 2 jumpers. Now, I'm not particularly fond of the fact that this jumper has a 90-degree angle in it. That's just me being fussy. It's perfectly fine. The electrons really don't care that it's got a 90-degree angle on it. It's maybe a little bit, catchy that could get caught and pulled up, but anyway, I needed to do that, and it was better than adding a 3rd jumper. So if you've got to put a 90-degree angle, well, go ahead, but it's nicer if you can get them perfectly straight. Now, one of the things that we have to keep in mind when we're making the jumpers here is that if we were building a true 2-layered board, true 2-layered boards have this fancy thing called through-hole plating. And if you ever look at your Arduino boards, you'll notice that this one doesn't have the holes on it. Bad example right here. Here's an example of a board that I've had made up that has through-hole plating on it. And if you look at your Arduino board or any commercially made board, you'll see that right here, this pad actually has a thin layer of copper going all the way through that hole. And so it's connected to the layer on the bottom side. Here's one of those Arduinos with a through-hole plated connection on it. And that lets you connect the top to the bottom at the same place that you have a pin put through there. They do that by drilling the holes first when there's no copper on the board, and then applying the copper to the board afterwards. We're starting with a board that has copper on it, and we're removing the copper that we don't want, so we don't have a quick and easy way to get copper inside those holes on our board. So we've got to design our jumpers a little bit more fancy than they do on a true 2-layered board. So any top layer routing that we're going to do, we're going to have to do by hand, because if you look right here where I want to run this pinhole to this jumper right here, I have to do a little trace on the back. So you can see right off this pin, I have to come over here, I have to get away from that hole, and then I have to create something called a via. And the via is what goes through the board. And then I could solder that on, and then I can take this out here, and then I can punch another via through right onto that side, and then I can take it through and connect it to the pad where I actually want to solder my component. So anytime we put a jumper, okay, we're going to use vias just like they do on the professionally manufactured boards, but we have to move it just a little bit off of the previous hole. If this was a true 2-sided board, then that would just come right through, and instead of this being a wire, it would just be a trace on the top side of the board. I'm sure because I'm putting this out there on the internet, there will be people saying, oh, you can make a 2-sided board in your shop, and they'll have all sorts of ways to go about doing it. Well, you're not making them in my shop that way, because I have yet to see the way that makes it work. Now, also before I get into this too far, I should point out that although I've given you a schematic right here with values that are going to work, you can play around with some of these values and you can get slightly different results. So for instance, on this design right here, I changed up, and I don't know if the magnification on here is going to be good enough to show you. Which one was it that I changed up on here? I think R3 glows blue, gray, yellow. So R3 on here is supposed to be 10K, but on here I've got blue, gray, yellow, which is like 58K or something. Uh-oh. Okay, I'm not sitting down to figure out the color code on that one. But anyway, it's a higher valued resistor than is called for on the schematic. And you'll notice that when I turn this on, and let me turn off the light so you can really see the lights on there, that when I run this one right here, that the sequence travels about quite a bit slower than it does on the procrastinator. Okay, so within a few multiples of the value, you can usually play around with the values for the capacitors and the diodes on there. Sorry, the capacitors and the resistors on here. And this one you'll get spinning about this fast. And something like the accessometer where I use the 10K value in there, that's going to spin so fast that you can't actually see it spin on a 30 hertz camera. So if you want to slow things down, use a higher value in R3 right here, or a larger value for C1 right there. And if you want it to keep going in a circle longer, okay, and make the person waiting for it to settle out a little bit longer, you could use a larger value capacitor up here. This is just a 1 microfarad. You could put in a 2 microfarad capacitor, or you could try playing around with the resistor values in right here. Now, my favorite way to design something like this, as you know, would be to use a microcontroller and program it. But I have been convinced that not everything has to be a JSON programming project. So this is a classic circuit made with the 555 timer, which is one of the all-time great chips. And it's done probably more for hobby electronics and educational electronics than any other chip, including the Atmega that's in the Arduino, because it's just been used on so many things. And having a couple of classic chips like the 555 timer and the 4017 lets you create a neat little project without any programming and lets you explore what changing some of the values of components can do for changing the behavior of your circuit. So you've got the ability to play around with some of those values when it comes time to build your circuit. And I'll have another video going through how to go about constructing and building the circuit. And I'll post that a little bit later on because sometimes things happen when you go through this toner transfer process. Anyway, let's take a look at how we're going to route this board. Oh, got to come over. No, where have I got? I've got to come over here to shrink this down. All right, I'm just going to pull that off to the side. I'm going to shrink myself down a little bit to get out of the way so you can see what I'm doing on your screen just a little bit better right in there. Okay, so now we've brought these parts onto the board. Now, if you're wanting to make the round version of the board, okay, then we can do that too. You've got the board shape option right up here, and you can tell it you want an outline circle, okay, and then I would draw that starting in the middle right here, and probably start out bigger than you think you're going to need. Now, this board right over here that I started with is, now I should measure it in inches because this is all laid out in inches. This was my easier routing board, and that one was about 2.8 inches in diameter, and this one that was a little bit harder to route, that one was getting down to 2.25 inches in diameter. Okay, so anyway, on here, there is 2.5. Let's take that out. Let's make a 3-inch diameter board right there. Okay, and done. Now you can also take these lines right here and you can get rid of them, and you can see that now that has transferred everything over onto the board, and now you can move your parts onto the round board right there. Okay, now if you want the round board to work out really nicely, you do have to do a little bit of trigonometry. Yay, trigonometry. Okay, and you have to figure out, well, if I've got, let me bring this back up for a second here. Okay, if I've got 10 LEDs that are going to be on the board and they go around a 360-degree circle, okay, you're going to have board set up like that. And I shouldn't have drawn that horizontal in there because nothing lines up on the horizontal. You're going to have 36 degrees right in here, 72 right in there. What's your next one going to have? 36 onto there. So that's going to be 108 degrees coming right down there. And then you can do sines and cosines to find exactly what position you want your LEDs to be at as you come around in regular spacing. And if you want them to be able to bend outwards like this, then you've got to have them lined up so that they're positioned this way so they can bend outwards. Now on the procrastinator, which is a rectangular board, and I'm going to take a look at designing a rectangular board now, but I wanted to show you how to do a circular if you wanted the circular. I just lined them up vertically, okay, right like so. And I also lined them up so that I could bend them over to the side. So they're pointing upwards right now, but I could bend them over to the side like these ones are so that they actually illuminate the words right here. Problem is, I kept these words in a little too close. If I'd moved them about one letter over that way, the LED would have worked perfectly and it would have illuminated them and it wouldn't be shining up in the camera right now. It would be shining over here, illuminating that. But I forgot that these are 9 millimeters tall and I didn't leave 9 millimeters of space right in there to bend them over. So they point upwards. I'm okay with that. Yeah, I've got the example here of them bent over to size, and there's an example where you can apply your trigonometry to figure out the positions for your LEDs. And when you've got the positions figured out and you want to put your LED into place and you want to control the angle, just click on the LED and there's your positions right there. Now, you'll notice that when I drew that circle, I drew the center of the circle at location 0, 0. So the position of your cursor is showing up right there. And you can figure out where your cursor is and where things are. And you can actually type in the numbers right here for what angle and what position you want your LEDs to be at. Okay, so if you're going the round board route, that gets you started on there. Works out really nice. I'm going to go back and do the square board route. I think it route's a little easier, but I'll be more impressed if you figure out the round board and get all your LEDs mounted nicely on there. So I'm just going to take this back and let's give ourselves a rectangular board right on here. Okay, now try not to make your rectangular board too massive. Okay, and keep it nice and rectangular while you're doing it. And maybe start out by moving some of this off to the side. And you'll notice that your LEDs are all numbered. Now you want them to go into sequence, and this is part of the routing problem that you're going to have. So what you're going to do is you're going to start off with LED 1. Oh, let me just pick up LED 1. It's going to come up over here somewhere. Now, if you're doing it procrastinator style, you can actually use your top layer to put the text right on here. So it can all mount onto one board and you can figure out what text you want to go in there. If you want the LED to be able to bend over and point towards that board, angle it so your LED pins are in there vertically. So careful to make sure you get these in sequence. LED 1, where's LED 2? LED 2, and leave enough space for your text to show up. LED 3, okay, I think you've got that figured out. I'm just going to pause this for a second, put those into order. Okay, let's see. Yes, I'm back recording again. And as you can see, I managed to get these all sorted so that I've got LED 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all lined up there. And while I was doing that, I also took the time to take their names and make sure that they're nicely aligned right on there. Actually, I think those should tuck in just a little bit closer. There we go. And so I've got all that lined up right on there, and I've got my LEDs ready to go. Now, the next place that I'm going to look is I'm going to go back and take a quick look at the schematic because all of these LEDs match up to R5. So 5 is going to come off the ground for right on there. So I'm going to grab R5 in here somewhere. R1, 2, 3, where's R5? There's R5, and I'm just going to bring it down right there. And yeah, I'll put it right there for now. Okay, I don't know if that's where I want to have it permanently. In fact, I don't 100% know where I want all of my stuff to go just yet. You can see I've got a big mass of tangly air wires running between all the LEDs and the 4017 chip. The 4017 chip takes pulses from the 555, and it's what controls the LEDs and controls which one of them is on. Okay, so I'm going to have to put it somewhere. I'm going to move a few things out of the way here so that I'm going to put my on-off switch right up over here. And I may as well put the battery up next to the on-off switch because those ones are tied together. I'm going to bring my 555 in here. And I'm going to put my IC in here. Now you'll notice that I'm just putting things down and I'm kind of giving them space, but I'm going back and I'm taking a look at my schematic and I'm saying what things are kind of together. So the base of the transistor and R2 and R1 all meet up. So if I come over here and I say, okay, well, where's my transistor? There's my transistor. There's the base. Okay. So I'm just going to find some space up over here. I'm going to get that capacitor out of the way for a bit. R1, okay, and R2 are all going to meet up at the base somewhere on that transistor. It looks like that one, R2, also meets up with the emitter. So that's going to be handy. I'm going to put that right there. I'm going to put that in right there and keep those ones kind of close together. And it looks like they also connect to this little jumper that I'm going to put my finger onto. So again, you can put that somewhere on the board. You could use, a big copper pad for doing this. This is what you're going to touch your finger on to make it run. I just left the jumpers on here because the jumpers allow you to put an easy wire connection on there. Then if we take a look at the schematic over here, we can see that R3 and R4 are going to meet up with C1. Okay, so let's come back over here, and this is this is C2. Okay, C2 looks like it wants to go in there somewhere. I'm not cramming things in too tight just yet. C1 wants to go with R3 and R4. There's R4 is right in parallel with it. And I'm going to bring R3 over close to it right there. Okay, now this board's probably bigger than I want it to be when it's all done, but now I can start routing things. And when I see a complex board like this, part of me wants to route it myself, and part of me wants to get a little bit of help. And this is where the Autorouter can come in. Now, a couple of things. The Autorouter, well, you come along here and you say, auto-route it. And you just continue, and you click start. And bang, it's got it 100% routed. How easy is that? Okay, it's going through and it's optimizing things and trying to find the easiest way to go about doing it. Look at that, it's got it all done with no vias. And of course, we can't make that in our shop. You could send that off to a manufacturing plant. They can make that for you, no problem. But we can't make that in our shop. Okay, and the reason we can't make it is it's using these incredibly fine lines. Look at how close they are. And, maybe you could make one board that good using our shop processes, but you're not going to make a class set like that. And if you do try, all of the flaws are just going to come back to haunt you when the students come back to tell you what's wrong with their board and ask for help solving it. That's kind of on you. So what we're going to do is we're just going to hit unroute, and we're going to unroute all and get rid of all that. Okay, bang, we're back to air wires. That's okay. That wasn't going to work for us anyways, but it gave you an idea of some of the cool stuff that an Autorouter can do. What we're going to do now is we're going to come to rules DRC, and you'll remember this is a really important part of the project because the DRC is where we set all of our rules for the board. So for clearances in here, I like to go with 25. Now, if you're going for a smaller board, you can go down to a clearance of 20 thousandths of an inch or 20 mil. But if we can do 25, that makes it a lot easier later on when you're manufacturing the board. So I'm just going to come through and put 25 in here everywhere. And the vias are those little holes that we're going to add later on to get from the top layer to the bottom layer. Okay, and I'm not going to worry about this because this is for surface mount devices. The distance to the edge of the board, actually we can take that out a little closer than 40 thou. So if you're doing a small board, you could take it down to 20. This board's still pretty big right now, so I'm going to leave it up at 40. And the size is the minimum width of our traces. 25 is nice. That's about the size of one of the fine tip Sharpies. So if you need to, cover up your toner a little bit, if you have an imperfect toner transfer and you've got space, a width of 25 and a spacing of 25, you can get a Sharpie in there and you can take your fine tip Sharpie and just draw along over top of that to make sure that you don't etch away too much. But anyway, leave it at 25. If you're doing a really small board, you could take that down to 20. In fact, on this board right here, taking that down to 20, let me get the routing done with just 2 jumpers on it. Okay, our annular rings, again, the ring is the diameter of that little pad that you're looking at right on there. So each of these solder pads on here, we need them to be bigger than 10 mil. Now, we're not too worried about the top layer because we're not going to have pads on the top layer, but let's set these up to 20 to begin with. Okay, and we're also going to have some vias. They're going to be on an outer layer, and let's set them up to be 20 as well. Okay, and if I click on that and just go apply, you'll see some of those diameters come up a little bit bigger, and we cancel that. Make sure we didn't make them too big. You can see it's giving us a little bit of warning that now we can either make these transistor pads bigger or we need to make the spacing between them smaller. We had a little bit of a clash right there. Same thing here on our capacitor. You're going to have to be careful about soldering those up that you don't get solder jumps between the two of them. But having the extra meat on the pad, okay, just means that when it comes time to drill and solder, you've got a little extra copper to play around with there. And in general, so long as these aren't actually touching, you're probably better to have the bigger pad than you are to have the bigger gap. Looks like those two have come together pretty close too, but we're still going to be okay here and we'll benefit from that little bit of extra copper on the bottom when it comes time to actually making this. Now that we've set some rules in here, okay, if we run the Autorouter, so let's come back to design and quick route and Autorouter, and we're just going to, well, let's let it go here. Continue, start. The Autorouter comes through, and once again, it tells us that it's 100% of the way done, but now you can see it's got a whole bunch of stuff on the top layer, which again, that's fine if you're sending it out for manufacturing at a plant that builds the boards by drilling the holes first and then plating up the boards. That's not how we do it in the shop. So we got to end that job and we've got to unroot all of that. And that's sad. So bang, there we go. We're back to air wires again. This time when we do the Autorouter, you'll notice that it gives you a choice right here when it talks about the top layer. And it lets you hit NA, so it's not available, just like all these middle layers are, because we're not making a 16-sided board with sandwiches of copper layered in between layers of fiberglass. We're just making a board, and we want it all to go on the bottom. So we'll let it go through and auto. And I just don't like anything doing a low effort. So turn it up to medium, and let's see now what happens if it continues right here and we click on start. And it starts processing through right here. And actually, we've got so much space on this board now that it's coming through pretty nicely. I see one of the solutions has come up to 93.5%. Okay. And you can see it still hasn't quite finished. It's still running some roots down here. It's thinking about these ones in the background. but it's showing us a few things that work. 93.5. Okay, and actually, some of this routing's looking pretty nice. And we'll just let it finish running these routes right here, see if it comes up with anything better than 93.5. Now, one of the reasons we got to 93.5 really quickly is because I have spent a couple of, uh, let's say a couple of hours, maybe more than a couple of hours, playing around with arranging them. So I did have some kind of idea where to drop these onto the board. Okay. Um, but I'm not happy with 93.5. That's still going to leave me with 3 jumpers, and I know we can get it down to 2, and I want to see if anybody can get it down to 1 or 0 jumpers. Okay, so after we do that, I can click on the 93.5, and this shows me what it looks like when it does the 93.5% routed. And so I can click on End Job, and it'll show me the air wires that are left. There's one air wire right there. I need to figure out how to route into there. There's the other one. I need to figure out how to route from there into there. And there's the other one. I need to figure out how to route from there into right there. But aside from that, everything else up here has been done pretty nicely. Now, one of the things that you want to watch for is you want to say, do I have areas where things are getting crammed together? Because can I move those things apart? Can I use that to help shrink my board? And you can see up here, I've got a whole bunch of empty space. Down here, things are looking pretty nice. That's routed around there fairly good. And the other place you want to look for is, do I have places where things are all twisted around? And excuse me. Um, Again, I don't have those because I sort of started you off with a solution that I knew was going to be pretty close, but you might have areas where things are twisted around. You might need to play with your placements a little bit. So I want to make this board a little bit more compact. I see I can move this in here a little bit. I can move that down a little bit. I can bring this in here, and I can bring all of this in here. So I'm going to unroot it all. Okay, 93.5 is my best so far, but I'd like to make the board a little bit more compact because a big board wastes materials. And I think I can bring that in about to there. I can bring that in about to there. This can probably come down about to here, about to in here, and a bunch of this stuff can come in right here. Now, one of the things about this capacitor is you'll notice that I like to sometimes have my capacitors sit flat on the board. And so you can see that where the leads go in, I just leave space to fold that over and lie it down. And what that makes it is a little bit easier when you're trying to design it and pack it into a case. This case in particular that I had in mind when I was designing the board, that sits a little bit flatter, so it's an easier fit right into there. Okay, so I'm moving some of this in right here and using up some of the space on my board just a little bit more wisely, still leaving lots of room in here for the traces leading up to the LEDs to be routed around. That one might fit in there more nicely like that. That one might fit in more nicely like that. You can see that I've kind of flipped that around to straighten out some of the lines. There's my on-off switch. And here's my battery. Oh, let's see. And then I can bring this side of the board in about like so. And now I'm working with a little bit smaller board and I'm saving some space. And let's see what the Autorouter comes up with this time. We'll use the same settings. Continue, start. Oh, I might have put it together a little too close. I'm only seeing 91.3 come up as my max so far, but there's lots of ways it can route to 91.3%. And usually once you see those ones locked down, you don't see too much improvement down here, but you can see those numbers are creeping up. Your processor will also be working pretty hard while this is going on because it's trying Many, many different combinations and permutations. Looks like we lost one of our connections right in here at 91.3 because we were at 93.5. This is going to be a 4-jumper board. Just going to pick one of the 91.3 configurations. You can check out the different configurations and see if there's one that looks nice and makes sense to you. And I can still see room to shrink things down a little bit. And let's see, now there was 4, and those are all coming up from down in here, and it figures it didn't have room to route those through. Now, you could say, gosh, I wonder what happens if I take that and let's unroute. Let's unroute all of them. And what happens if I take this and flip it around that way? Okay, it looked like it was routing nicely before, but we can play around with some things right on here. And the Autorouter makes it pretty quick to try different settings. Where'd my Autorouter go? Is it giving up on me? There we go. I just had to hit escape, and so I got out of move mode. And continue and start. Oh, there we go. We're back up to 93.5. It is a little more efficient. Oh, 97.8. I have not achieved a 97.8 routed board before. I've done 95.7. Oh, maybe it is going to be possible for someone to get 100%. Well, let's go to that 97.8 routing, and let's say we're going to be happy with that. And now we want to finish this off, and we want to turn this into a board. Oh, here's another 97.8. Oh, I'm excited about this. This is the best results I've had. That's a nice square layout. That one's also kind of nice. Let's see. I think I like that one. Just, more process in the line. Well, I think this one gives us more room to move the lines apart though, okay? Because we can shrink this board down even a little bit more, but I'm gonna end this job right here. And you can see we've only got one thing to route left right in here. Okay, so what we're gonna do for routing this one right in here is now we're gonna have to put in a jumper because it needs to come all the way from up there, all the way down to right here. Now, I can't start right from that pin. I have to come out a little bit, so I'm going to start in here somewhere, and ideally I'd run one jumper all the way down here, and you can see that at the space in between these two lines, I could run a bottom layer line right into right there. So I just need to create a little bit more space for myself to do that. Okay, so I'm going to come in here, and I'm going to take this line, just move it out a little bit. Okay, and then I'm going to take, oh, actually, no, I want to move this one in a little bit. Now, ideally, I don't want to get these two crammed together because if you can give yourself a little bit of extra space, that's just going to make etching your board that much easier, okay? Like out here, we can move these out a little bit and those out a little bit. And that just makes etching those traces right in there a lot easier. We'll come through and we'll clean up some other stuff later on. But let's take a look right up here. And now I can move some of this stuff in the middle down some so I can give myself more space over here, and I can move it in this way a little bit so I can give myself more space over here. So for instance, this line right here doesn't have to be right there. It can move in like that. And this line right here, oh, let's move Kind of have to move some of this together in sequence, I guess. I should have just picked it all up as one big chunk and moved it as one big chunk. Now I've got it all out of alignment. This can actually come down in here and be fairly close right in there. That can come up in there. That can move over a little bit. Oh, clean that up just a hair. There we go. Get it nice and tidy in there. Bring those out so that they're away from the board. There are ways that you can play around with how it's doing the routing to get that nice and neat. I'm going to bring that down there. This I'm going to bring down. I might, oh, it's not letting me. Oh, there we go. Let me rotate it. I wanted to rotate it the other way. That's not happy. And undo that rotation. I'll just bring that down there. Bring that in there a little bit. Bring that over here. Bring some of that down so that I can bring this down. And I can bring that resistor down. Bring that resistor down. Bring that line down. Again, when you give yourself lots of space, you've got lots of options. And that's one of the reasons why making a rectangular board is going to be easier for you than making the circular board, and certainly making it larger is going to be easier than making it smaller. Now, the purpose of bringing all of this stuff down, and let me, yeah, it's happened right there. Bring that down nicely right in there. There we go. Of bringing all that down is to give myself just a little bit more space right in here. So I can space this out nicely. And now what I can do is I can do my jumper, because there's no way that this section that's circulated by all those wires is going to be able to get out and come down here. Is there? Because that would have to slip up in between that line, have to slip up in between. Oh my goodness. Could that possibly fit? No, it can't fit with the spacing we have, because I've already got these lines right here occupying all the space underneath the board, and it can't come out around there because it would have to cross that one. But that's okay. I wanted to show you how to do a jumper anyway. So to do a jumper, what we're going to do is we're going to make sure we're on the bottom layer, okay? Because we are going to now do a manual routing just like we've been doing. Come in here and make sure you're on the blue layer until you get away from any objects. And then click right there and hit the space bar. And you'll notice when you hit the space bar that that little blue dot shows up in there. That's your via, okay? And then you're going to click to put your via right there. And you'll notice that when you do that, that it switches to say you're in the top layer now, and that you're drawing in red, because this line that we're running all the way down to here is going to be our jumper on the top layer. And we're going to draw a nice straight jumper all the way down across the board to a spot like that. And we're going to hit space to get a via right there. And then I'm going to click. And now I can take that in right here. And that completes the routing for that jumper. You can see that it kind of bumped out of the way of that resistor right down there. So I can hit escape. I can grab the resistor, move that out of the way, and straighten that back out so it looks like a nice straight line. And there is your board routed with one jumper or one wire that we're going to run on the top to take care of the wires running all the way down here. Now, there's some other things I'd like to do. You notice I've been spacing my wires just a little bit more. So anywhere where you've got them really close together, just go in there and say, hey, can I tidy that up just a little bit to give myself a little bit more space for soldering? and in case something goes wonky with my etching, that I've got a little bit of an out and a way to fix it. Sometimes you'll also see things like this that look a little bit weird, and you can tidy them up just like that. Right down here, this blue line, I've got lots of space there. Move that over and tuck that in here. Here, those two don't need to be as close together. That can come down right in there. This one doesn't need to be so close in there. Let's just bring that down there. Tidy that corner up. Oh, that's looking a little bit ugly. What's going on right there? Okay, we'll leave that. Bring that in there. Okay, get some things out and away from some of those pins if we can. This one could come up over there to give that pin a little extra space. That one can come out there. That one can come out there. Yeah, that's probably fine in there. Give that one a little bit more space right there. These lines coming up and down the side are all pretty close together. So let's give them a bit more space. We can move that one in right about like so. That gives us some space there. Give ourselves some space right there. And give me as much as I wanted. This can come out there a little bit. This one can tuck in a little bit. That's looking not half bad. It is a slightly bigger board than I made with the procrastinator, so there is room to compact that down a little bit. You don't want to be wasting too much space. Like I think everything could shift in just a little bit over to that side. But I'll leave that up to you to figure out how to solve on your board. The key thing is that when you get stuck and it won't route 100% of your lines for you, well, that's where the jumper comes in. And to make the jumper, you have to do blue on a bottom layer, space bar to get the via, click to lock the via in place, draw the line, preferably one nice straight line, but if you have to put a bend in it, you can put a bend in it. Don't get too fancy with the routing. Oh, there is a little bit of a problem here that this resistor is going to intersect with it on the top layer. Let's try. Can we move that resistor over this way just a hair? There we go. Now that resistor won't intersect with it on the top layer. I've got no components on the top layer that are going to intersect with that. Remember, that's going to be a physical wire on the top layer. And just if you look right in here, down in the bottom corner here, you can see that because that wire is sitting right on there, I don't want it intersecting with a resistor that's running over top of it. So there we go. One jumper comes down here, bottom layer out to a via, top layer, which is just going to be a wire that we put in right there, down to another via, down to bottom layer routing that takes us to the pin that we want to be at. So that's in place pretty good. Now we are going to want to go through here and tidy up some of our numbers and all that, like you can't see which resistor number that is. We also want to add some holes to here because you're going to want mounting holes for the board, but you may also want to use the holes to provide a little bit of strain relief. So you can see right down in here, I've got two holes punched so that when my LED is my battery is dangling off here while I'm carrying this around and showing people how it works, because I haven't got it into a case yet, I'm not straining the solder joint because I've wrapped this through a couple of bigger holes right down here on the board. And same thing right on here. You know, this board right here, my battery line is soldered right here, but it comes down through there, runs along the back like that. And now when I tug on that, it's physically restrained by the board instead of by the solder joints. If you try to hold the board by the solder joints, that wire is always going to snap at the solder joints, usually about 30 seconds before you go to demonstrate it to a student. So make sure you've got some strain relief in there. The other thing that you may want to do, and I forgot to drill out this little hole right here, I marked it, is because I plan to set this into a case and 3D printer machine or whatever, make a case, even just use some standoffs and mount it on a piece of wood. I wanted to be able to take some wires and run them down to the back. You can see my battery goes through and it comes out on the back side right here so that I can hide the battery in the back. You might want some bigger holes for mounting and getting wires back and forth from the top layer to the bottom layer. So to do that, we're just going to go place a hole. And if you want to use a number 6 screw, you want to create about a 150,000th of an inch clearance hole on there. So just put in 150, and then you can come in here. And while you're moving around, you can see the location of it pop right up on here. So you can see that that one is at 1050 in the X by 3300. So if I come down here and I want this one to match up really nicely, I'll say, let's put that one at 1050. That's at 200. And if I want to put one out here, I can put this side in later once I put some text onto here. I'll put that at 200 in the Y. And this one was at 5550. So I'll come up here 5550 and 3300. And that way they should all be lined up nice and squarely. And I can shrink my board down a little bit like that, a little bit like that. And as I was saying, you probably also want one of those holes for where your battery comes through so that you can have a little bit of a strain relief, or at the very least get the battery wires out to the back of your board. But on this board, there's enough places to put 2 holes right in there so we can route that through to the back. Okay, so you've got mounting holes and you've got wire holes popped onto your board. Now, one of the things that we're going to do on here is that we are going to do the toner transfer for the top layer right on here so that you can use that as a guide for assembling all of your components. Oh, there's just one small problem in here. How did that get overlapped with another component? I'm just going to have to move that out of the way a little bit. And it doesn't matter if these 2 wires touch because they're one and the same wire. So I'm just going to move this whole thing actually one notch over. That shouldn't be. There we go. Clean that up. Clean that up right in there. And now that's not intersecting with the battery symbol and it won't give me an error later on when I look at it. Okay, so that's all in there like that. I've got some holes mounted on the side. Let's come into our layer manager. So over here, we've got our layer set. If that's not showing up, there should be a button up here that lets you go in there and see layers. It's right around in there somewhere. But tell it you want to look at the preset top layers. And now that gets rid of all the stuff on the bottom. You can see everything on the top. And you can go through and you can arrange the names of your resistors so that you can see which one's going to be R4 and which one's going to be R3. There's C2 in fairly small text. Every part designer used a slightly different font, which is a little bit annoying, but you're not responsible for their choices. So we can put Q1 for the transistor, R2, well, don't pick up the transistor. Don't pick up the transistor. We liked where it was. Just pick up R2, put it above or below, wherever you want. They align at different points. You can actually go in there and adjust the alignment. You can see alignment right on there as bottom center. We should be able to go top center. What's that one? Bottom center, top center. I guess that's because we rotated the resistor originally a few different times. Anyway, that's pretty close to nicely aligned. JP1's easy to read. G1, let's get it out of there. That's just our connector. Our 9 volt, the plus and the minus are going to be pretty easy to read. C2 showing IC1. Let's just flip that around so that it's easy to read. You'll notice that it's got a notch on here showing us the correct direction for installation. IC2 is right here, and it's got a dot showing us where pin 1 is going to be. R5 showing on there. That's looking pretty good. Now, let's add a little bit of text to it right here. Okay, so you can come over to Document and Draw, Text, add some text to a drawing. And this is where you can enter all of your options for what you want to show. And let's see, what are we going to have for options on this one? Who's going to win the Stanley Cup? No, that's ridiculous. Anyway, come up with some interesting options. Come up with some text on here. And option 1, okay. Now you'll see the text is pretty small right now. Let's bump that up to, let's see, how big is 200 mil? If we come in here and we should be able to see that text appearing right on here. Oh, that's because I'm still drawing on the bottom layer. Come in here and you're going to draw this in on, well, we can actually put it in on the top layer, but probably top dimension is, T values is probably a good place to put it. Or T names, that works as well. And then document, draw, text, option 1. 200's a little too big. 150. Sometimes you have to click on something else to see it shrink down right in there. Now, like I was saying, I left that just a little bit too big. Go ahead and position these on here so that they look nice and orderly. And leave space for that LED to fold over. And then you can come back, and when you click on that, you can come over here and you can edit it to be option 2, and you can click on this one. That can be option 3, etc. Okay, and then, we should put a title up top. We might need to move this board up just a hair so that we can come through and draw text, enter text, title. Okay, and let's make this one 250. No, 250 is a bit big. 200. And you can run a title along the top. In fact, maybe what we'll do is say done and just click on that and it'll say, I don't know, big fancy title for your board. Now, if you want to make sure that that always stays aligned, even when that gets edited, you can come through here and tell it the align. You want center, bottom center, and then you can just drag that right back to the very middle of your board. And that way, if you change your title, it remains aligned onto your board, whereas these ones remain, what's that, left justified so that they slide back and forth, and you've left enough space to fold the LED over here so it can highlight them. And so you can call this the procrastinator, and then you can have all your different options on how to procrastinate, or you can have it for, I don't know, favorite ice cream flavor, and you can have all your favorite ice creams listed on right here, or anyway, come up with something creative, have a little bit of fun with that. If you can shrink the board down a little bit, then that's great, because the less material you use, the better. That board, one of the reasons it routed nicely was because it's a little bigger than this board. If you can get a small board with only one, or better still, no jumpers on it, although I kind of do want you to use a jumper. If you can get it down to one jumper on a smaller board, I'm going to be really impressed. And if you can get smaller than I've got right here, well, I'll be more impressed still. If you do go that small, you can go down slightly smaller and maybe take your spacing down to 20 thousandths of an inch. Okay, well, we've got the front of the board done up like that. Remember that we're also going to take a look at preset bottom, and we've got a lot of space left in here. And let's go into the bottom layer again. And remember to put your name on the bottom. So document, draw, text, and 4017 555 roulette. Okay, yeah. I don't know, original design is ancient, so I'll just say redrawn or April 2023, J. Brett, BCIT, TTED. And you know what? That's ridiculous to make it that large, but look at all the space. Oh, actually, that wasn't a good place to put it. Just a minute. You saw it intersected with that, so maybe I did make it a bit too big. Document, draw, text. Anyway, 4017 555 roulette, drawn April 2023, J. Brett, BCIT, TTED. Put your name on there. Take some ownership of it. Let's take this down. 150 will be plenty. And we can slap that right in the middle right there. And done. You weren't doing anything with that spot on the back of your board. You could draw a picture on there. We're not using it for routing anything. We're just using that so that when we take a look at preset standard, okay, now you've got all your options on the front, you've got your stuff drawn on the back, and if you've drawn your schematic correctly and you come into your design rule check and you go check, and it'll give you some warnings. Now, no vector font, we're okay with that, okay? All that means is that it's like, hey, you put words on the bottom. I don't want that. Gives you 6 clearance warnings. So let's take a look at where they are. Well, we knew that capacitor was going to be a problem, so we're okay with that. There's not much we can do about that. That's a component thing. This one right here, between those two pads, again, when we increase the pad size, which is a good thing to do, those ones got kind of close together. Okay, oh, where did my errors go? Design rule check, check. That brings that back up. And the transistor, well, we knew about that one. We knew about that one. Where's that one pointing to? We knew about that one, and we knew about that one. I'm not going to get too worried about any of those clearance errors. Now, if it tells you that you've got traces crossing or touching, or you've got air wires remaining, then you've got some problems that you're going to have to sort out. Okay, so this is saved and ready to go. So a good idea to hit save right now and give it a name. So this is 4017 555 demo. Okay, and now that's saved right into here. And our project now has our schematic linked to our board. It's passed the design rule check. Our board has some holes in it so that when we go to mount it onto a case, we've got a way to mount it onto a case. And now what you can do is you can print this out. Now, because we're printing this out for manufacturing, you have to be pretty careful about what you do. So here's how you get it off your computer. First of all, we want the bottom layer. Okay, so go to your preset bottom layers. Make sure everything looks okay right on here. And then come to Document and hit that Print button. Printer's borders are larger than the current values. Sure. Okay. Make sure your scale factor is set to 1. Okay. And you are going to print to one of the BCIT printers. We actually want a physical copy of this. You do not have to mirror the bottom layer. The bottom layer comes to you already mirrored. Okay. You don't have to rotate it. If you have problems fitting it onto the board, you can rotate it. So maybe that actually works a little bit better because you're away from the edges. You don't have to do upside down black. If you want a caption on the bottom, that just says who made it. But the key thing is scale factor of 1, black and solid. Okay. And you're going to print that out on a BCIT printer. Okay. Now, once you've got that one printing, okay, you're also going to click cancel on that. I mean, you're going to print OK on it to get it to print, but if you're happy with it, you go ahead and print. Then you're going to come back here and you're going to go preset top. Okay, and so now you've just got the top layers, including this line showing you where you're going to add a wire for that jumper. And you're going to go print. And on here for preset top, this one you do have to mirror. Again, make sure your scale factor is 1. Make sure it's mirrored. Okay, and the black and solid are turned on. Okay, now why is that bottom line showing up there? Oh, maybe it shows up better in this view when it's mirrored. It's probably just got to do with the rendering. I expect it'll show up just fine on the printer, but this one's looking nice in my preview, so you can go ahead and print that one out. And remember, the top layer does have to be mirrored because it's going to be flipped over. Okay, go ahead and print that one out. And once you've got those 2 pieces of paper, it's time for you to watch the next video about how we're actually going to manufacture the printed circuit board. Okay, good luck with that and have fun. I'm looking forward to see how small you can make the board and how few jumpers you can get on it, all while having manufacturable trace sizes. Let's see, just to give you an idea, this one, like I say, has a lot of leftover space and 2 jumpers on it. And that one right there is, what's that? 3.7 by 3.8. So basically 3 3/4 inches square. And this one right here is much tinier. That one's round. And it is, where are we? 1, 2, 2 1/4 inches in diameter. So when I'm doing my marking, okay, if you give me a board like this and it works, I'm going to be happy. And, you know, yay. If it's a little bit bigger, well, you know, maybe a little bit less of a mark. This one does need to have a certain amount of blank space right over here, just so that we can do the toner transfer and put all the titles right onto here. Okay, so this one is probably going to be a little bit easier than cramping it down onto a smaller board. Now, if you come over to a round board, chances are you are going to be making a slightly smaller board right here because you're going for more of a roulette style. And this board right here would, well, it would score a little bit higher than this board because it's got less board space, but at the same time, it's got 4 jumpers instead of 2. And this one right here would be even better because it's a more compact arrangement. It's a little bit harder to do. And again, it's only got 2 jumpers. Could I get something like this down to 1 jumper? Well, when you look at the back, there is room to optimize things. And now that I know that it can be done with 1 jumper, I'm wondering, can it be done with 0 jumpers, which would kind of negate the point of showing you how to make a jumper. Anyway, once you've got that all done and you've got that printed out, then it'll be time to go on and manufacture the board. One more cool thing that you can do with this is that if you go back to your, in your board right here, you do have the option under design right here is to push this through to a 3D printed circuit board, and you can say push. And Fusion, being Fusion, will come in here. Now, it doesn't have the models for all of your components. Okay, so the LEDs don't have a 3D model in there, but this gives you a 3D model of your board right here. And you can actually use that 3D model to start building a case around your board. So I actually ended up doing that right in here. So for the roulette case, when I modeled that up in Fusion 360, it all started out because I took my 3D model of the wheel, or 3D model of the board, and I can turn a few things off in here, get rid of the battery, get rid of component one, and that was my model right in there. And then I came in here and started designing some various components around that. Oh, let me turn that on. There's the base and there's the battery door right down there. So I started building components that would fit right around the board, and then I put this piece right in here, and then later on I just came in and in AutoCAD ended up designing the little acrylic piece that goes right over top of it right there so that I can come up with a mark. How did I do on this video? Oh, it's taken a long time to figure out how I did on the video. C minus. Oh, this must have been the people who wanted paper handouts got to this. Anyway, I much prefer paper handouts too, but for some things like doing a video demo, it's hard to pack the instructions and the step-by-step into there. I hope this has helped you out, and I hope look forward to seeing your creative designs and what you do with these various projects. There's a lot of high school electronics teachers out there having a lot of fun making little roulette wheels with their students. Remember, you can change up some of the components on there. You can play with some of the capacitor sizes and some of the resistor sizes. Just check, maybe don't change them too much. Don't change them like an order of magnitude or anything like that, but you can change them up a little bit and you can make things blink slower or faster and spin for longer or shorter period of time. Have some fun with that, and good night.